make coffee.
Moose Science Gal, did you make dirt coffee again like you did earlier? Yes, silly. Hey, friends. So we're sporting our sleeveless flannel because it is hot today. Woo! We are going to do an experiment today that is dealing with food and the energy that's in food. So we are actually going to burn a pecan. Or you can use whatever nut maybe that you have, of course, only if you don't have an allergy, right?
Also,
go ahead.
These nuts, these are really good. All of you should have these except for the peanut allergist because they make you
strong.
They have lots of protein.
Right, but what is protein and what is energy? Because this week we're kind of looking at food webs, aren't we, Moose Science Girl?
Yeah.
Okay.
Well, if you think of it, protein makes you stronger.
Right. And it also is energy that lasts longer.
Yeah.
So you don't burn it off as quick. But we want to talk about that we're using energy we're taking in food for energy. So here's the experiment we're going to do, and you're going to need to have a parent supervising this because of safety. And the first thing we're going to do is we're going to deal with fire. So we have got to get our gorgeous hair, pulled back. So, Moose Science Gal, can you get us our fabulous headbands? Wow! Thank you. Okay, so you want me to do mine first, and then I'll help you, Moose Science
Oh, yeah.
Gal? Okay. Whoo, I got to be able to keep my hair. All right. Whoo, you got some crazy hair, Moose Science Gal.
I curl it every day.
I know you do. Oh, probably that's not going to work over your head. Oh, my, Moose Science Girl.
Wow.
Gal. Oh, here we go. All right. Woo! We look like rock stars. We are rock star scientists. Okay. So, first thing we're going to do, you're going to get 2 cans. Okay? You're going to have to take one, and you're going to need to cut it. Okay? Can you show everybody that, Moose Science Gal?
Should be like a phone.
Okay?
Hello?
Right. So, this is, by the way, friends, this is aluminum, and this is very sharp. So, I used an X-Acto blade, but be very careful. So, have your parent help you. And then I took the top off. That's going to be the bottom. That's going to hold. Moose Science Gal, are you into the pecans, eating them?
I'm sorry, they give me great protein.
Oh, she is. She gets in that stuff all the time. Inside this can, we're going to put 100 mils of water. Now, we have 100 mils of water. Now, this is a measuring cup. You probably have. But if you look on the back, it's in milliliters, which is the metric system. Okay? So, will you put 100 mils in there? And we're going to do something also pretty weird. So, we're going to use this cool thermometer. Okay? If you have a regular thermometer, that would work too.
These are awesome because...
Right, this is digital.
You're in the Moose Science Girl and Gal kitchen.
Right. And we're going to stick this in there because we want to know the temperature before we start. Okay? So we're going to leave this so you can see the difference. So it looks like we're about 54 degrees Celsius. Hey, Moose Science Gal, we need to write that down.
Oh, yes.
Okay? We need to write that down. The other thing, okay, because we're getting ready and then we'll move so that you can see. The other thing that we need is something to hold the nut. Because we're going to put the nut and we're going to put it on fire. So, all of you...
Celsius is like ice and Fahrenheit is like heat.
Oh, Moose Science Gal. You know that's not. Now, which I think what you're trying to say is 0 degrees Celsius is freezing. And 100 degrees Celsius is boiling. So, but Celsius is metric. That's what we use in science, Moose Science Gal.
Where else is it used?
Any place that uses the metric system. So we don't use that necessarily here in the United States as much, except we always use it in science. But most of the time, if you were to go to the doctor, Moose Science Gal, you would have your temperature measured in Fahrenheit, not in Celsius.
So right now, if I got my temperature taken,
you'd be 98.6 Fahrenheit.
Oh.
Okay? The other thing that we're going to do is we're going to take a paper clip, and I'm going to bend this large paper clip. I actually have 2 here because the bottom of the can is kind of rounded up. I'm going to leave it rounded up. It's just the regular bottom of the can, but this is going to hold our nut. Now, we chose a pecan.
Again.
A pecan.
Again, nut allergists don't do this.
Right.
Try something different.
Right. So we're going to put, let's see if we can get this. All right. I'm going to put this in here. And I'm going to kind of stick our nut in here in between that paper clip. I might have to pull this out. Alrighty. There we go. Kind of like this. See how it's staying? And I'm going to kind of put another paper clip in here to kind of stabilize it a little bit. Hopefully. Okay? So we will move this down a little bit so you'll be able to see this maybe a little bit better. Okay? But we also want you to be able to see the temperature, okay? Because we're going to light this on fire, okay? So, are you ready? Now, Moose Science Gal, do you have the extra water just in case we need it? Because we are playing with fire.
Wait, isn't that a movie?
Oh, playing with fire? Good one. Gosh, she is on fire. Oh,
here.
All right. Are you ready?
Ready, scientist? So
Okay.
I'm going to come over here, and I'm going to put this up here so you can see it.
Oh, but don't let it black. All right, here we go, Moose Science. Gal, go! Oh, dear me. That's all.
Sorry.
That is okay, Moose Science Gal. You know, mistakes happen all the time. What do? Should we cry? No. Moose Science Gal, don't cry. It's not a big deal. But let's be careful because we don't want this to tip over when we get... So I don't think we have to move it. Okay? All right, let's light this on fire.
Here we go, science friends.
I'm going to light this from the bottom because you're going to be amazed how this really takes off.
Wait.
And it's kind of stinky. So I'm just going to kind of warn you. I'm going to light this the other way too. And we want this to burn a lot. We want the whole thing to burn. Okay? And if we don't think the whole thing was burning, we can light the rest. But I think it looks pretty good. Let me see.
If you're really quiet, you can hear sizzling.
All right. Oh my goodness! Look at the temperature, up 2 degrees already. Because remember, friends, we also went and wrote down already. We already wrote down 54 was where we started. Oh my goodness, it's up to 58 already, Moose Science. Don't be scared. Remember, we're doing this in the kitchen, okay? So, and I'm also doing this on a cookie sheet.
Should I turn the apartment?
No, Moose Science Gal, we got this under control.
Okay.
But it is kind of stinky, so maybe afterwards we'll
Open the door.
We'll open the door a little bit because it is kind of turning. It is putting off some black smoke, and that's okay because we're not going to worry about it. But we have this. This is controlled. There's no paper around. We're not tipping it over. Maybe I'll just open up the door a little bit. Unfortunately, our Moose Science Cat might come in.
Oh, hi, Moose Science Cat.
We have a Moose Science Cat.
Moose Science Girl, why is
Okay.
it going down? It went from 50 to 30.
Oh, my.
What has happened?
What? Well, that's not right.
Well, science friends, give us a minute. We have to figure out our
What is going
technical
on?
difficulties.
What is going on? That is not correct. Why is it going down?
Huh?
It's going back up.
What the heck?
What is going on? That's not correct, is it? I wonder what's going on. Maybe we should go into Fahrenheit,
Yeah,
Moose Science Gal.
I think that would do better.
Whoa!
Whoa! That
The only thing we'll have to go back is Moose Science Gal will have to go back and measure the original temperature. Boy, that is really no Moose Science Gal. She faints when things get really crazy in here. So we're still burning. Hey, this is still burning. Oh my goodness. Okay. Hey, Moose Science Gal. I'm gonna go ahead and I'm gonna put in some water.
Here, I got the water right here.
Oh, you do have some water that we've had. Wait, no. I'm going to leave the water so we can measure the temperature.
Oh.
Holy mackerel, we're up to 111. I wonder what that temperature is like to begin with. So notice, this is still burning. It is getting smaller. What do you notice, Moose Science Gal?
Well, it's a little bit flickery, so it might be getting done.
Okay, I have a really important question.
Wait.
It is
smells
kind of
like
stinky.
The brown beans in here.
Oh my gosh, and it's up to 114 degrees. All right, are you ready, science friends? I have a really important question for you. Is this chemical or physical change?
Well, here comes our expert, Moose Science
Oh, Moose Science Gal, what's your answer?
Chemical change.
Most-
Can you change something that's melted?
Well,
well-
yes. Yeah, you can. But
No.
this isn't melting. This is burning, okay? So here's what we're going to do, friends.
It's a chemical change.
It is a chemical change. We're not going to put water on this. Here's what we're going to do. So if you notice, it was up to 114. Write that down, would you, Moose Science Gal? Okay, 114 degrees. Okay, I'm going to put this into our room temperature so we know what it should have been to start with. Because for some reason, our thermometer did not read correctly, did it? It should have totally not went down. So what is it normally? Let's see, 72. We'll let it sit there for a little bit.
It was at 54, so maybe it will get down to 54.
Okay? And then what we're going to do is we are going to go back and we're going to measure the mass of this. Now, we happen to have a balance here. Maybe you have a balance at home, and if you don't, that's okay.
Mass? What's mass? Isn't
Oh.
that like a fish? Like a mass in a bass?
Mass is a measurement of condensed molecules, okay? We measure it in grams, okay? It's how much matter. So what we're going to do is we're going to go back and we're going to take the mass of this after it's burned. Because a famous scientist said matter cannot be created nor destroyed. So if this lost mass, where did the mass go? Well, the mass went into heat energy.
Would this
Okay.
be mass like Moose Science Girl?
No, that's not quite mass. Mass is grams. Okay?
Oh.
Mass is grams. So if you don't have that, that's okay. But what I'm going to show you a little bit later on our Moose Science Girl Facebook page is how you actually calculate calories. Now, calories are like what's on the back of this that says calories. 220 for a serving size of a quarter cup. So what does that mean? And I'll actually show you how to do that on the Moose Science page because you can figure out calories.
Holy cow,
Okay.
friends, do you see that? Look at this bottom of the can.
Right.
Look at the can underneath. It's completely burned.
I wonder, Moose Science Gal, if we tried different types of nuts, do you think we'd have different results?
Yeah.
Huh. So, you know what? If you don't have pecans at home, use walnuts, use peanuts, use pistachios, use whatever you want. We're not going to put water on it, Moose Science Gal, because I don't want to change the mass. So we're going to just leave it. Oh, look. Looks like we were about,
4 degrees.
74 degrees. So that's important. So stay tuned. I'm going to show you how to mathematically calculate the calories with this pecan, okay? Well, thanks again, friends, for joining us. This was a pretty exciting
Oh, man.
lab experiment about food energy, okay?
That's my nice hair.
Oh, I know. We got to go do our hair now. All right, friends. See you later.